Here we go on Chapter 2A, revision of expansion. So remember when we're expanding through and multiplying through a set of terms within a parentheses, we're going to want to make sure that we distribute to everyone. So A times B is AB, A times C is AC. So in example 1 here, remembering that sign is associated with the 3, so that negative 3 needs to be distributed to that x. So negative 3x times x is going to be negative 3x squared. Then we distribute it through here, and I get negative 3 times 2 is negative 6x. On example 2 here, what we're going to see is we're going to need to distribute for both of them. So here I'm going to do y times 3y, and I get 3y squared, and y times negative 1, and I get negative y. Over here, I'm going to multiply the negative 3y, remembering to carry that sign with it. So I get negative 3y times 2y is going to be negative 6y squared. And then negative 3y times a negative is going to be plus 15y. Now at this point, I want to make sure I simplify by collecting my like terms. So I identify my y squared terms, 3y squared, and a minus 6y squared, and I get a minus 3y squared, and a minus y and a plus 15y is going to be a plus 14y. That's my simplified solution there. Okay, going on, we can look here, example 3. So when we're double distributing binomials, we have two terms. We have to make sure we get all the combinations, meaning we got to do a times c, then we got to do a times d, and then we got to go with the second term, b times c and b times d. Okay, and then simplify and collect like terms. So here on the first one, we're going to have x times x, that's x squared. X times negative 3 is minus 3x. Then we're going to take our next term, 4x. 4 times x is 4x, and then 4 times negative 3 is minus 12. At this point, we're going to collect our like terms. Most binomials, it's just the middle two terms that are similar, so we can combine those. So then the x squared stays there. Minus 3 plus 4 is going to be a plus 1x, and then minus 12. And that's my simplified expansion. Here in example 4, the difference of two squares. So when we multiply out difference of two squares, we should identify that the terms a and b are the same, but the difference is the signs in between. So notice here in example 4, that is that case. So what happens is we just have x squared minus b squared as our final term. Well, let's see why this is what happens. So when we do 3x times 3x, we're going to get 9x squared. We do 3x times 2, and we get plus 6x. When I multiply here, this negative 2 times 3x is a minus 6x. And minus 2 times a plus 2 is a minus 4. So as we simplify these, when we have these conjugate pairs, meaning that this one's negative and this one's positive, these cancel out. So I'm just left with 9x squared minus 4. Notice it's the difference minus of two squares, 9 being a perfect squared and 4 being a perfect squared. Here in example 5, what we are doing is we're a perfect square of itself. Well, instead of trying to memorize this equation, just realize that something squared is something times itself. So I can write this as 3 minus 4y times 3 minus 4y, and I execute it just like I did before. 3 times 3 is 9. 3 times 4 is negative 12y. 4y times 3 is negative 12y. And then negative 4 times negative 4y is a plus 16y squared. When I collect my like terms, I'm going to want to try to write it with my highest degree term first. So I'm going to get 16y squared. Now minus 24y, because I collect these two as my like terms, and then a plus 9. Notice it fits that equation up there, but instead of trying to memorize this, just let's make sure we understand when we square something, it's something times itself. We can expand that out. Example number 6 is coming from chapter 2b, further expansion. These expansions are going to deal with larger case scenarios where we might have 3 terms as opposed to 2. Well, if we just know that we're multiplying by every single term, we just have to add a couple more steps. So here, on this one, as I multiply this out, I'm going to do x times x squared. So I get x cubed, x times 2x, and I get plus 2x squared. And then I get x times 4, and I get plus 4x. Now, I need to do it with the 3. I'm going to take 3 and multiply it through every term on my second product there. So 3 times x squared is plus 3x squared. 3 times 2x is plus 6x. And 3 times 4 is plus 12. So now that I've multiplied those all through, I have 3 terms in red, 3 terms in blue. I'm going to collect my like terms. So I only have one, x cubed. Now I should have 2x squareds. So that's going to be plus 5x squared. And I should have 2 x terms. So that's plus 10x. And just one constant term, plus 12. And now, not only can I multiply a binomial by a trinomial, but using this same pattern of making sure that every term here is multiplied by every term here in the second parentheses, I can do any polynomial multiplication regardless of how large it is. So here, if we have 3 linear terms, I can multiply them together. So what I'm going to do is I'm going to break this off, and first I'm just going to multiply those 2 terms together. So first I'm going to do x times x, that's x squared, then x times negative 3 minus 3x, and then 1 times x is plus x, and then 1 times negative 3 is negative 3. When I simplify that, I have x squared minus 2x minus 3. But remember that over here, I haven't multiplied it through on this term. And I can multiply this by x plus 2. Okay, so now as I distribute this through, I'm going to multiply my x squared. So I'm going to do x2 times x, and I get x cubed. I'm going to do x squared times 2, and I'm going to get plus 2x squared. Okay, now I'm going to multiply the second term, negative 2x times x, and I get minus 2x squared. And then negative 2x times 2 is going to be minus 4x. And now my negative 3. Negative 3 times x is minus 3x. And minus 3 times 2 is negative 6. So as I collect my like terms, I get x cubed. My x squared terms are opposites, so they'll drop out. And so then I have minus 4x minus 3x. This is minus 7x. And then I have minus 6. Okay, and that's my simplified form. That concludes our notes here tonight on chapter 1 and 2. Please highlight any questions you have and bring them to class tomorrow.